Hello, and welcome to the second part of the course on Six Sigma Yellow Belt. In this module, we will discuss the 7 basic quality tools, the types of data and DFSS. The 7 basic quality tools are 1. Tally sheets. 2. Flow chart or process map. 3. Histograms. 4. Cause and effect diagram. 5. Pareto diagram. 6. Scatter diagram and 7. Control chart. Before we get into the details of 7 basic quality tools, let us become familiar with the data types. Data can be broadly categorized into 2 types. The first type of data will be continuous data, and the second one would be discrete or attribute data. Continuous data are measurable by some physical instrument, and the value is continuous. It can be any number including decimals, but does not need to be integers. For example, weight, height, length, and density. Attribute data is countable, and must be represented by integers. Attribute data can also be classified as good or bad. For example, number of defects or defectives. Having discussed the concept of data types, let us now have a look at the 7 basic quality tools in detail. The first tool that we will discuss is tally sheets. Tally sheets are a very important tool for data collection. Inputs gathered from tally sheets or check sheets can be used to create Pareto diagrams, fishbone diagrams, etc. The purpose of tally sheets is to ease the compilation of data in such a manner that they can be used or analyzed comfortably. They are a simple and convenient recording technique for collecting and determining the occurrence of events. They are constructed with each observation to give a clear picture of the facts. What are the steps involved in creating tally sheets? Step 1. The first step would be to determine the objective by asking questions, such as: what is the problem? Why should data be collected? Who will use the information being collected? Who will collect the data? Step 2. The second step would be to decide the features, or characteristics, and items to be checked. The third step would be to create a tabular form for collecting data. Traditionally, the features, characteristics, items, type of defects, etc. are listed on the left side of the check sheet. Step 4. The fourth step would be to collect the frequency of data for the items being measured. Record each occurrence directly on the right side of the check sheet as it happens. Step 5. The next step would be to tally the data, by totaling the number of occurrences for each category being measured. The next basic quality tool that we will discuss is the histogram. Let me describe what histogram is, and the information it shares. A histogram is a visual representation of variable data. It organizes data to describe the process performance, and display centering of the data and the pattern of variation. It demonstrates the underlying distribution of the data. A histogram can be used to check whether or not the data is normally distributed. It provides valuable information for predicting the future process performance. And it helps identify whether the process is capable of meeting process requirements. What are the steps involved in creating histogram? Step 1. The first step is to collect the variable data in a table. Step 2. The next step is to ensure that all the measurements are in the same unit of measure. Step 3. The third step is to arrange the data in ascending order, such that the minimum and maximum value can be identified. Step 4. The fourth step is to choose some suitable interval length of uniform size. Step 5. The fifth step is to use a check sheet to count the number of observations corresponding to each interval. The number of observation for a particular interval is said to be the height of that interval, and displayed as vertical bars. A sample diagram is given here where the raw data displayed in the form of a histogram. Some of the important aspects to be considered when studying a histogram. Firstly, location of the mean of the process. Secondly, spread or variation of the process, and thirdly, shape or pattern of the process. The third basic quality that we will discuss is the flow chart or the process map. What is the flow chart or process map? It is a graphical representation of processes in an organization, displaying the sequence of tasks performed in the relationships. It is a prerequisite to understanding of a process, before application of quality management tools, such as FMEI, SPC, etc. Process maps are progressively elaborated. A high-level process map is defined showing major processes. It is made more explicit and detailed, as project team develops better understanding of all the processes. Standard symbols are used in the creation of process maps. What are the benefits of a process map? First, it helps clarify several process steps, and process flow, which may not be understood clearly before. Second, it shows problem areas, unexpected complexity, redundancy, idle time, unnecessary loops, and where simplification may be incorporated. Third, it visually shows the various alternatives possible, and helps in selecting an appropriate solution. Fourth, it helps all members of the team gain appreciation for the work being done by others in the team. It compares and contrasts the actual versus the ideal flow of a process. And last, it can be used as a training tool. Next, I will explain and show you the symbols used in the process map. The first symbol is a rectangle. The rectangle represents a process step, or action taken. Each process steps has one or more inputs, does some activity, and create one or more outputs. The next symbol is a diamond. The diamond represents a decision step. Options from possible alternatives is selected depending on the input to this step. The third symbol is an oval. The oval represents the start or stop of a process map. It is also used to depict if the process map continues to on another page. The fourth symbol uses in a process map is an arrow. The arrow represents the direction of flow in a process map. Now, when you know the symbols in a process chart, what are the steps involved in creating a process map? The first step is to put together a cross-functional team, which has knowledge of the process, and appropriate subject matter expertise to create the process map. The next step is to define the process and its boundaries, including the start and stop points. The third step is to describe the stages of the process in a sequential manner. The fourth step is to assess whether the stages are in the correct sequence. The fifth step is to draw the process map using the conventional symbols learned earlier. And the last step is to have it reviewed by the people involved in the process, to check its accuracy. Let me explain the as-is, and to-be process map. First, try to find the existing process maps, which may already be in the company. Map all, as-is high-level processes, that is, processes as they exist now. This will create awareness within the team about the current processes. Let all team members understand the contribution of others. This is the as-is process map. Then ask the cross-functional team to study process, and identify opportunities for improvement. And finally, based on the inputs from cross-functional teams, map all to-be processes. This is the to-be process map. Next, we will discuss the cross-functional process map. When more than one function or department of an organization are involved in a process, which is very likely in general, we need to create a cross-functional process map instead of a simple flowchart. It is a simple process map along with the various functions displayed on the left side of the diagram. The sequence of tasks is mapped in such a way that they correspond to respective functions. It may be possible that some tasks are performed by two functions. These tasks must then be displayed in such a manner that they fall in both functional zones. The fourth basic quality tool we will discuss is the cause-effect diagram. What is a cause and effect diagram? It is the graphical representation of the possible causes, for any projected problem under the study. This tool is developed by Kaoru Ishikawa in the 1960s, to determine and break down the main causes of a given problem. This tool is employed where there is only one problem, and the possible causes are hierarchical in nature. This diagram is also known as fishbone diagram, because of its fishbone-like structure, or an Ishikawa diagram. It gives the relationship between quality characteristics and its factors. It focuses on the causes and not the symptoms. A cause and effect diagram is usually created by a group of people, who have knowledge of processes and understand the problems in the present system. It helps in finding the root causes of a problem, and in generating improvement ideas. It clarifies the understanding the team has regarding the process. If the Ishikawa diagram does not show an appropriate level of detail, it indicates that the team has a superficial knowledge of the problem. Therefore, additional study of the system, or involvement of subject matter experts is required. The steps involved in creating cause and effect diagrams are: first, the effect of the specific diagram, or quality characteristics make up the head, and the potential causes, and sub-causes of the problem, or quality characteristics make up the bone structure of the fish. Therefore, write the effect of the problem in a box to the right-hand side. Second, draw a horizontal line from the left-hand side of the box. Thirdly, identify the major categories for causes of the effect, which form the main branches of the diagram. Then the major categories for the main bone structure are the branches or the 5 M's: machines, manpower, methods, materials, and maintenance, followed in the manufacturing industry. Or the 4 P's: policies, procedures, people and plant, followed in the non-manufacturing industry. The team may identify other relevant major categories depending on the problem. Next, ensure the team members have proper knowledge of the process, and understand the problem under study. 5. After that, conduct a brainstorming session with all the team members, to generate the possible causes of the problem. 6. Then categorize the identified causes into groups and subgroups. A popular way to do this is by using affinity diagrams. 7. The next step is to write the names of categories above and below the horizontal line. Start with high-level groups and expand each group. 8. And, finally, write down the detailed cause data for each category. The fifth basic quality tool is Pareto analysis. What is Pareto analysis? It is a rank comparison of factors related to a quality problem. A Pareto diagram displays the relative importance of problems in a simple visual format. Since availability of money, time, and other resources are restricted, a Pareto analysis helps the team to consider only the vital few problematic factors, out of the trivial many, which if addressed with due care, will bring the greatest work with minimum resources. The Pareto diagram is based on the Pareto principle, also known as the 80-20 rule, which states a small number of causes, that is 20%, are responsible for a large percentage of the effects, that is 80%. The Pareto diagram is named after Vilfredo Pareto, an economist from Italy who studied the distribution of wealth, and documented that the distribution was not equal across the population. He confirmed that the majority of wealth is concentrated with relatively few people. Pareto's observation was popularized by Dr. Joseph M. Juran, who is regarded as the father of quality control. It was Dr. Juran who named the 80-20 ratio propounded by Pareto as the Pareto principle. Dr. Juran referred to those few contributors, who account for the bulk of the effect, are referred to as the vital few. He referred to other sources, that do not contribute significantly to the effect, as the trivial many. What are the steps involved in creating a Pareto diagram? The first step is to put together a cross-functional team with knowledge of different opportunities, or problems under study. The next step is to create different categories for the opportunities. The third step is to select a reasonable time interval for the analysis. The fourth step is to determine the total occurrences of events in each category. The fifth is to rank the total occurrences in each category from maximum to minimum. The sixth step is to compute the percentage for each category, by dividing by the category total, and multiplying by 100. The seventh step is to create a graph of opportunities with category names on the x-axis, and percentage of opportunities on the y-axis. Let us now look at an example of a Pareto diagram. This is the example of a Pareto diagram of complaints received at a restaurant over a period of 3 months. The restaurant management is concerned about the increasing number of customer complaints. The horizontal axis represents various types of complaints, and the vertical axis displays the number of complaints in each category. The right-hand vertical axis displays the cumulative percentage of the complaints. The blue curve represents this data. From this chart, we can see that only the first 4 complaint categories, food, ambience, service, and staff courtesy, constitute 80% of the total complaints. Thus, these 4 areas need immediate attention to improve process performance. The sixth basic quality tool is the scatter diagram. What is the scatter diagram? It is a graphical representation that depicts the possible relationship, or the association between 2 variables, factors, or characteristics. It provides both a visual and statistical means to test the strength of a relationship. Let's look into the other steps involved in creating a scattered diagram. 1. First of all, collect the data on both variables, preferable sample size is 20 or more. 2. Then plot the data points on xy plane, where variable 1 is plotted along x-axis, and variable 2 along y-axis. 3. The next step is to identify the linear relationship between them if it exists. 4. The final step is to identify the strength of linear relationship as strong or weak positive, or strong or weak negative. Let us now take a look at an example of scattered diagram. From the above scattered diagram, we can see that the factors x and y are having a negative linear relationship. Individual data points are plotted as bullet points and the trend line indicates there is a linear relationship. The seventh and the final basis quality tool is control chart. So what is a control chart? It is a tool used in the control phase of the Six Sigma project. It distinguishes special from common causes of variation. Common causes of variation are natural in the process, they are small in magnitude, and difficult to identify, and remove from the process. Special causes occur due to special conditions or events, are large in magnitude, and easy to identify and remove from the process. There are 3 major components of a control chart: upper control limit, UCL, lower control limit, LCL, and center line. Mean. Information required for a control chart is a count or measurement from a process, whenever an event occurs, or at regular time intervals. Let's take a look at a sample control chart. Here, the date obtained from a process is plotted on a chart as shown below. Let us now discuss the various components of a control chart. The first component is the mean. It is the simple average of the processed data. Displayed as a central line in the control chart, and individual data points are plotted on the chart. The next components are upper and lower specification limits, that is USL and LSL, obtained from voice of the customer. A process satisfies customer requirements, if it falls within the specification limit. The third component is the upper and lower control limits, that is, UCL and LCL. These are calculated from the processed data. If all the process data stays within the control limits, then it is very likely that the variation is inherent in the process. That itself is a common cause of variation. UCL and LCL lie within the upper and lower specification limits. If the process data lies outside the control limits, it indicates a special cause of variation. Having discussed the concept of the types of data in the 7 basic quality tools, we have now come to the last topic of discussion, which is design for Six Sigma or DFSS. We will now discuss the concept of DFSS. Design for Six Sigma or DFSS is an application of Six Sigma, which focuses on the design or redesign of different processes, used in product manufacturing or service industry or delivery, by taking into account customer needs and expectations. The acronym DMADV is a common DFSS methodology, used to develop a process or product, which does not exist in the company. DMADV is used when the existing product or process doesn't meet the level of customer satisfaction, or Six Sigma level even after optimization with or without using DMAIC. Companies using DFSS include GE, Motorola, Honeywell and many others. DMADV stands for Define, Measure, Analyze, Design and Validate. Define the project goals and customer deliverables. Measure the process to determine current performance levels. Analyze and determine root causes of defects. Design process in detail to meet customer needs. Validate design performance, and its ability to meet customer needs. This brings us to the end of the module. Thank you for learning with us.